In today's tutorial, we'll be looking at the characteristics of quadratics and their parabolas graphs. So let's get started. If you're following along in your notes, you're going to write this down in your table of contents on the appropriate page number. For today's lesson, you should be able to say that you can determine the y-intercept, the vertex point, and the axis of symmetry from a graph or an equation of a parabola. In order to do that, you have to be able to locate the vocabulary on the graph of the parabola, use your TI-84 calculator, and use appropriate formulas that you're going to learn in case you have to show your work and can't use your calculator. All right, so some of the characteristics that we're going to be looking at today for quadratic functions is learning that quadratic functions have a soft U-shaped curve, right, known as a parabola. So this here is a parabola. And when you read your graph from left to right, this part of the upwards facing parabola is moving downward, right? Even though it has an arrow pointing up, when you read the graph from left to right, your eyes move down. So this is decreasing. And then as soon as you hit this point here, the turning point, known as the vertex, the parabola changes directions and starts increasing. So you can have parabolas that face upwards, like we have here, or as you'll see in the next few screens, that face downwards, like we have there. Now every parabola, no matter which way it's facing, can have an imaginary line drawn down the middle of the vertex. So no matter where on the coordinate grid I draw a parabola, I can draw an imaginary line down the center, right? It's called a line of symmetry or an axis of symmetry. And we're going to be talking about that today as well. So let's take a look at some of these vocabulary words. So here's some visual representations of what we're talking about today. A vertex is a turning point of a parabola. The y-intercept is the point at which the parabola crosses the y-axis, and then the axis of symmetry is an imaginary line that you draw down the middle of the parabola that passes through the vertex point, right? So, remember, you can have two different types of parabolas. So for our studies, we will be studying upwards facing parabolas, that would be this one here on the left, and downward facing parabolas, that would be this one here on the right. So obviously, if I show you a graph, it's easy to tell me whether the parabola is facing upwards or downwards. But what if I were to give you just an equation? So that's what we're going to be talking about. Remember, a parabola starts to turn along its path, and that point is called a vertex. And if the point is the lowest point on your parabola, you call it a minimum. And if it's the highest point along your parabola, you call it a maximum. So you have a vertex here, you also have a vertex here, but you can characterize them in two different ways. One is a minimum vertex and the other one's a maximum vertex. Now if I gave you just an equation and I didn't show you a picture, you can still tell me whether that parabola is facing upwards or downwards. And this is how you know. Every equation, when written in standard form, has a coefficient here in this first position called the A position. And if your value in the A position is positive, then your parabola faces upwards. And if the A position number is negative, your parabola faces downwards, right? So this example here, my A coefficient is positive, so that's an upwards facing parabola. Now I might ask you a follow-up question, and I might say, okay, does your parabola have a minimum or a maximum? Remember, all upwards facing parabolas have a low point, called a minimum. So my follow-up question here might be, does it have a minimum or a maximum? And you would say, minimum. Let's take a look at the next question. How about this one? Without a drawing, could you tell me which way the parabola is facing? And could you tell me if it has a minimum or a maximum? So here's the coefficient of A, It's an invisible one, and it's negative. That is a downward facing parabola, and it has a maximum. Alright, I think you're getting the hang of it. Why don't you try these 3 questions on your own? Tell whether the parabola is facing upward or downward, and then decide whether it has a minimum or a maximum point. Pause the video now. Okay, you ready to check your answers? Let's see how you did. Good job. Alright, another characteristic that we might ask you to identify is the actual coordinates of the vertex point. So how can you identify a vertex if I give you a graph? That's simple. You find the coordinates of the turning point. So for us, the coordinates of this minimum vertex point is 3, -4. That's it. That's how you identify it from a graph. Now another thing you can identify from a graph is something called the axis of symmetry, or the AOS. An axis of symmetry is an imaginary line that passes through the middle of the vertex point. And if you were to fold your parabola over, it would overlap exactly. So an axis of symmetry is a vertical line, and all vertical lines are undefined, so they have an equation with only the variable x in it. So all axis of symmetry equations start with an x. They never start with a y. And the number that goes on the other side of that equal sign will always be the coordinate from your vertex point in the x position. So what is that x equal to? Well, for us, it was equal to 3. So if I asked you, what is the equation for the axis of symmetry, you would say x equals -3. I'm sorry, +3. All right, what if you didn't have a drawing? How would you find the vertex then? Well, unfortunately, when an equation is in standard form, you can't tell just by using your eyeballs and looking at it. If it was rearranged into a different format, you could figure it out, but that's for another lesson. For today, the first thing we're going to do is try using our calculator. How about if our calculator drew the picture for us? X squared plus 2x minus 4. I see my graph here. I see I do have an upwards facing parabola. Now, it's kind of tough for me to see. The screen's a little bit tiny for my eyeballs, so I'm going to teach you how you find the vertex perfectly without having to actually look at these little pixels. So you can calculate a vertex by going into your calc menu. Do you see it here above the trace key? So you need to press second, trace, and look what we see on the screen. We see a menu of vocabulary words, and for us, we're looking for a minimum, right? Because we had an upwards facing parabola. So I'm going to choose number 3. Now you see this question at the bottom of the screen. It says left bound. It wants to know if that cursor is to the left of the vertex point. And so I'm going to press my left arrow until I am on the left side. So now that I'm blinking on the left, I'm going to press enter. A little vertical line will appear. Then I'm going to move my cursor to the right. And I'm going to press enter again. And now the calculator is asking me, do you want me to guess? And yes, I do. Guess between those two imaginary lines, please. And I get my answer of -1 and -5. So using my calculator, I got a vertex point of -1, -5 by using my second trace calc feature. Now you can do this without a calculator. So, I mean, using a calculator is pretty easy, but my calculator wasn't functioning so well, so it actually took a lot longer than it should have. You can use this formula to help you find the vertex point. Now, it looks a little scary, but it's not that complicated, right? Every quadratic equation has values in the A, B, and C position. So this is the formula. Take the number from the B position, right? -b, so take the opposite of whatever your B number is, and divide it by 2 times your A number. So I'm going to take this formula, I'm going to move it off to the side here while I work. And I'm going to substitute in here a value and substitute down there a value. So my b value is positive 2 and my a value is invisible 1. So it looks like I'm going to get negative 2 over 2, which is negative 1. That will be the x-coordinate. Now the question is, how do you find the y-coordinate? Well, if you look up here at your quadratic equation, you have the letter y and you know the letter x. So you can simply substitute in for your x values the y value, the x value, substitute into your x value the number you just found. So you plug that in there. So y is equal to 1 squared plus 2 times 1, take away 4. So y is equal to, did I do that right? Oh, it's negative 1. I copied it wrong. It's negative 1. So I gotta back that up here. So that means 1 minus 2 minus 4, that's negative 5. And that makes sense because that's what I got on my last screen when I used my calculator. All right. Could you identify the vertex from this equation? So I'm going to use this formula because for me, it's a little faster than that calculator. This calculator's been giving me some trouble today. So I'm going to plug in my values here. So negative b over 2a. Well, that gives me a positive 12 divided by negative 4. So that's a negative 3. Now in order to find my y value, I need to substitute in to my equation, instead of x, the number I just found, negative 3. So I'm going to clear out my calculator here. And I'm going to type this in because I don't want to make a mistake. Negative 2, parentheses, negative 3, parentheses squared, minus 12, parentheses, negative 3, plus 6, 24. And that's that. All right, now here's the last vocabulary for us. The y-intercept is really easy to find. If you're looking at a graph, you find the point where it crosses the y-axis. That's it. So for us in this example here, it crosses the y-axis there, so the y-intercept is 0, 7. If you don't have a drawing and all you have is an equation, that's very simple as well. The y-intercept is also known as the initial value. And this number in the C position is the initial value. So that makes this our y-intercept. That's pretty fast. Now remember, it only works when your equation's in standard form. So if I were to rewrite this sentence, then without even looking at a graph, I could identify the y-intercept. The y-intercept is negative 4. All right, let's review the things that we've learned. We've learned that the y-intercept can be found by seeing where it crosses the y-axis or using the c value from the equation. The vertex point can be found by where the parabola turns or by using this formula to find the x-coordinate, plugging it into your equation to find the y. And the axis of symmetry always is an equation that starts with x, and it uses the x-coordinate formula. So let's try an example here. Remember, if you're asked to justify your answers, you have to show your use of this formula. Use a table of values to graph each function. Find the vertex, the equation of the axis of symmetry, and the y-intercept and state the domain and range. So let's see. I'm going to turn my calculator on, and I'm going to clear it out, my y equals button here, and I'm going to type in this equation, and then I'm going to look at the table of values and write it on my paper. This way, the person reading the paper will know what points I'm going to graph. So again, you can use any points here. I'm going to slide up a little bit and see if any of these values would fit on my grid. All right, well, 9 is way too high, but these values would work. All right, so here we go. X and Y. So my values were -2, 2, -2, 2, -1, 3, -1, -3, sorry, 0, -6, 1, -7, 2, -6, and 3, -3, and 4, 2. All right, let's get to graphing. -2, 2, -1, -3, 0, -4, 5, 6, +1, -7, 2, -6, 3, -3, and 4, 2. Now remember, quadratic has a nice soft curve. So if you have some graph paper, hopefully you can sketch some parabolas today. All right, so we created a table of values, we drew our parabola here, and now we're going to find the vertex. So since I have a graph, the vertex is simple to see. It's 1, -7, and the axis of symmetry always starts with an x, and it always uses the x value from our vertex. So x equals 1. The y-intercept is 0, -6, right here. And the domain is how far left and right, right? How far left and right. So it goes all the way left infinity and all the way right infinity. So we're going to use our inequality symbols here. Now our range is a little different because the graph does not go all the way down to -infinity. It goes down to -7, and then it goes up. All right. Why don't you pause the video? If you have some graph paper, give the graph a try. If not, at least try to identify these other parts by using your calculator. So pause the video now and give this a try. All right, ready to see how you did? Here are the solutions. Pause the video to check it over. All right, let's end this lesson here with 4 questions, right? So remember, when you're asked to determine these items, be sure to show all of your work, right? Be sure to show all of your work like I did here. All right, it's your turn. Pause the video and try these 4. All right, ready to check your answers? Pause the video, look over your work. And here's the next 2. Pause your video and look over your work. All right, that concludes our lesson on vertex, axis of symmetry, and y-intercept.